Okay, last one. So we've looked at cosecant, gotta look at secant now. So first thing to remember is that secant is the reciprocal of cosine, 1 over cosine. Cosine, remember, on the unit circle is your x coordinates, and think of it as 1 over x. So as we go around the circle, we're just gonna basically take the reciprocal of the x coordinates. So in my table, when I'm at 0, reciprocal of 1 is 1. At pi 6, I kind of went ahead and already wrote these outside, but this is coming from just the reciprocal would be 2 over square root of 3. I just rationalized it. So this is 2 square root of 3 over 3. I'm going to go right around the circle, square root of 2, 2. Get up here to pi halves where it's the reciprocal of 0, and that is undefined. And then negative 2, because cosine, remember, quadrant 2 and 3 is negative, so negative 2, negative square root of 2, negative 2 square root of 3 over 3, and then negative 1 at pi. Negative 2 square root of 3 over 3, negative 1, negative square root of 2, negative 2, and then again at 3 pi halves it's undefined. And then positive 2, because we're back to the quadrant 4 where cosine and secant are positive, square root of 2, 2 square root of 3 over 3, and then back to 1. Okay, so the first thing I'm interested in is looking at where the asymptotes are going to go. So you're going to see an asymptote here at pi halves, and the 3 pi halves, of course, where the graph is undefined. And so, again, with secant being the reciprocal of cosine, it's helpful to go ahead and graph the cosine graph first, and then use that to kind of let things fall into place like the asymptotes and so on. So remember cosine, good review of cosine. Cosine at 0 is the x coordinate 1. At pi halves, 0. At pi, negative 1. 0 at 3 pi halves, and back to 1 at where it started at 2 pi. So again, I'm going to use a little broken graph just so we know that that's not really part of the secant graph, but it helps me locate the things I need. So here you'll see where cosine is 0, that's where secant's going to be undefined. So at pi halves, asymptote, undefined. So asymptote there. At 3 pi halves, asymptote there. Where the graph is, where the cosine is 0, the secant will be 1 over 0 will be undefined. Okay, and so that kind of helps me see where things are going to fall. Just very much like the cosecant graph at this point. At 0, cosine is 1, secant is reciprocal of 1, so it's going to be 1. So this is not only going to be a point on the cosine graph, but also on the secant graph, as is this, and as is negative 1. All right, what happens between, what's the rest of the graph going to look like? Well, you know, I can plot some additional points there. At pi thirds, I know that the graph is going to be at 2, so I can come up here. All right, and so what's happening between pi halves and 3 pi halves and 3 pi halves? In the middle of the interval there, negative 1 at pi. At 3 pi fourths and at 3 pi fourths and 5 pi fourths, we've got some of these extra points I can plot there, but let me go ahead and put the 2 pi thirds, negative 2. And, you know, I can plot some extra ones in there, but since we kind of know what the graph's going to look like, I'm not going to plot all those. But. All right, but just remember that every point on the cosine, every point on the secant graph is just the reciprocal of that point on the cosine. So where the secant is negative 2, the cosine is negative 1/2. They're just reciprocals of each other. And then likewise with this one. All right, so that completes one, again, from 0 to 2 pi. You get the one full period or one full cycle of the graph. But the cosine graph, again, is not part of the graph. Just helps me realize where the asymptotes are going to fall and where the max and mins are going to be, and so on. Those key points really, again, you know, you can plot as many points as you want to in here, but if you kind of know what the graph looks like, I can get by with just hitting those key points, which is typically from here on how we'll graph that. Now, if I were to continue on, you know, this is going to complete this. If I went on this way, we would get to see the rest of this, but within one period, that's what it looks like. It assumes every value, but it's going to assume If I go around the circle again, I'm just repeating those same values, no new values are introduced. And that's pretty much this secant function. Okay, so let's wrap this up with the graph of our last function. We saved secant for last here. So the thing again to remember, just like with cosecant, that secant is the reciprocal of cosine. So secant is equal to 1 over cosine, or 1 over x, if you want to think of, since cosine is our x coordinate. So basically we're just going to, as we rotate around, we're just going to be graphing the reciprocal of the x coordinate. All right, so starting at 0, the reciprocal, the x coordinate is 1, reciprocal of 1 is 1. All right, moving to pi 6, we have the x coordinate is square root of 3 over 2. We're going to take the reciprocal of square root of 3 over 2, which is 2 over square root of 3. And you know me, I can't leave it that way, so I'm going to rationalize it, 2 square root of 3 over 3. And as I go to pi fourths, the reciprocal of square root of 2 over 2. Again, 2 over square root of 2, but I can't leave it that way, and so it simplifies to be square root of 2. And then at pi thirds, the reciprocal of 1/2, which is 2. Get to up to pi halves, and we have to take the reciprocal of 0. Well, the reciprocal of 0 is 1 over 0, which is undefined. All right, so let's go on and rotate on around at 2 pi thirds. So reciprocal of negative 1/2 is negative 2. And again, I can use the fact it's cosine is the x, and so in quadrant 2, the x or the cosine is negative, so it's going to be the symmetry with the same values, but they will be negative. So speed that up a little bit. And then when we get to pi, the reciprocal of negative 1 is negative 1. All right, again, if you notice the values, as we move on around to 7 pi 6, the reciprocal of, again, the x is negative in quadrant 3, the cosine is negative, so really going to repeat the same using the symmetry here, negative 2 square root of 3 over 3, negative square root of 2, negative 2, and then at 3 pi halves, the reciprocal of 0 is 1 over 0, which again is undefined. Okay, let me go ahead and finish the table up since I've almost down to quadrant 4 here. So reciprocal of 1/2 is 2, reciprocal of square root of 2 over 2 is square root of 2, and the reciprocal of square root of 3 over 2 is 2 square root of 3 over 3 after it's been simplified. And then again back to 0 where the reciprocal of 1 is 1. All right, so let's look at where this graph, again, I like to go ahead, even though the cosine is not part of the actual graph, it helps everything kind of fall into place. So I'm going to go ahead and graph just with a broken curve the cosine graph. So good review of that also as we go back to the cosine. Remember, when x is 0, cosine is 1 because it's the x coordinate. So, and then at pi halves, it's 0, and then it's pi, it's negative 1, back to 0, and then back to 1. Nice smooth curve. I'll do it broken because it's really not part of the secant graph. It just helps me find the secant graph. Kind of helps things fall into place. So anywhere cosine is 0, which was at pi halves, see it in the table and on the graph here. Anywhere the cosine is 0, at pi halves and at 3 pi halves, the secant is undefined because it's the reciprocal of 0, which is undefined. So my asymptotes will go at pi halves and at 3 pi halves. And at those points, there will be a break or discontinuity in the graph. There's no graph there. All right, if I go ahead and put in, so at pi fourths, for example, here at pi fourths, the value is square root of 2 over 2. At 0, I should start there, is at 1. Remember, the 1 is on the cosine also. The reciprocal of 1 is 1. So 2 square root of 3 over 3 is about 1.15. Square root of 2 is about 1.3, so a little bit higher than that. So you get that picture of the curve there. Between pi halves and 3 pi halves, what's going on here? Well, between pi halves and 3 pi halves on the circle here, or in the table here as you're looking, the values are negative, the x coordinates are negative, and so therefore the
the secants will be negative. At pi, the cosine is -1, so the reciprocal of that's -1. So this is not only a point on the cosine graph, it's also a point on the secant graph. And again, I could pick, I can plot the reciprocal of negative square root of 3 over 2, which is -2 square root of 3 over 3, which is about 1.15, and it would be -1.15. And at 4 pi thirds and at 5 pi thirds, it's going to be -2, so I can kind of estimate those. And so, but again, just like with the cosecant, each one of these points is just the reciprocal of its corresponding point on the cosine graph. And then again, as I finish here, and this completes one full cycle. One full cycle within 0 to 2 pi, the graph has assumed every value that it's going to assume. And so the period of secant, we say, is 2 pi. But again, just like with the cosecant, this is not really part of the graph. It just helps me see where the graph of cosine is 0. That's where secant's going to be undefined, and I know where to put the asymptotes. When cosine is 1, the reciprocal of 1 is 1. The reciprocal of -1 is 1. The reciprocal of 1 is 1. So those are going to be points on both the cosine and on the secant graph. And again, each of these other points is just the reciprocal of its corresponding point on the cosine graph.